Hi, everybody. This is Andy Ellicott from Crate, and presenting with Dominic today, our head of professional services. We are going to take the next 30 to 45 minutes talking to you about the anatomy of the Crate machine data platform, and really meant to help those of you building new applications that process machine-generated data do so in a very productive and successful way, and share some of the learnings that we've experienced over the last 6 to 12 months building the new Crate machine data platform on top of the CrateDB database, and hopefully those learnings will help you guys do the same in your projects. Just a quick word on logistics before we get into the real content. So you can, as we go along, we'll have a little Q&A session at the end. So if you have questions that come up during the presentation, feel free to type those in the questions panel. And recording of this event, as well as the slides, will be shared with you via email afterwards, so you can watch them at your convenience or share them with colleagues if you'd like. Okay, so the agenda today, we're going to talk briefly about the era of machine data and artificial intelligence, and a little bit about how those are changing data management and what new data management requirements they present to people and challenges. And then we're going to get into the technology and talk about the new Crate machine data platform, as well as the CrateDB a little bit. We'll talk, Dominic will talk to you about going to some of the internals of the machine data platform and a little bit about how it was built, and again, some of the learnings that we acquired along the way. And as I mentioned, we'll wrap up with Q&A. Okay, so some of you probably fall into one of these categories, right? Building smart factories, smart cities, smart vehicles, smart fill in the blank, right? So smart systems today. People are recognizing that machine-generated data, artificial intelligence, machine learning can be used to create new systems, operational analytic systems that are capable of helping businesses and things, factory equipment, vehicles, optimize and make course corrections, if you will, several times a minute, right? Historically, that's something that a business would do every month, right? Just kind of do the retro on last month. What did we learn? How can we improve? Or maybe on a quarterly or even an annual basis. But increasingly, companies have the technology and the competitive drive to build smarter systems that really allow them to optimize much more frequently and gain and reap the benefits of those optimizations, namely, higher safety, higher security, higher profit, lower costs, etc. Okay, so what's really different between today's analytic data projects and is really this last bit, right? So taking data from sources, in the case of our customers, it's usually machine-generated data from factory equipment, from IT infrastructure, from connected cars, and so on. And this is really like to be thought of as sensory stimuli, right? And just like our own brains, we're using intelligence or artificial intelligence in the case of these systems to analyze that data in real time and to react to it, and then take actions just as your body would, in response to a painful stimuli or something like that. And this is one of the reasons why our CTO and co-founder calls these systems operational brains. So really building analytic systems that are designed to take action and correct things as soon as a learning is acquired. One example of these systems is a smart factory project at Alpla. Alpla, if you have not heard of it, is the company that makes, probably makes your shampoo bottles, your beverage bottles, but it's a $4 billion leader in the manufacturing of plastic packaging. Make, again, bottling and plastic packaging for brands like Coca-Cola, Unilever, L'Oreal, and Procter & Gamble, many others. And what they've implemented over the last year is what they call centralized mission control. The problem they were having was, they've got factories around the world, I think around 170 factories. They have manufacturing production lines in each of these, about 1,500 across the world. And they had people on the factory floor who are trained to optimize the equipment, keep it running efficiently, making repairs, tuning, etc., documenting reasons for downtime so that there are learnings across factories and so on. But that workforce is expensive, right? And not just to have that talent and expertise that's required, but turnover is a problem for Alpla, right? So either through retirement or resignation, the knowledge that the factory floor workers would leave from time to time, and that's expensive. You've got to replace that person and kind of bring them up that learning curve all over again. So the bright idea they had was to, why don't we take the data generated by sensors on the machines and route that to what they call their centralized mission control. So this room, like you see in the picture here, a room in which a handful of these experts are watching data from the production lines and the factory equipment from across many factories, and they're able to tell what's running well and what's not running well. And that they're being informed in real time. If they see something that's starting to, machine that's starting, or process that's starting to behave suboptimally, they will they'll get in touch with somebody on the factory floor, and through either sort of tablet computing or even more cool, HoloLenses and augmented reality, step people on the factory floor through whatever tuning or repairs are required, and making sure that repair and that solution to the problem resolution is documented. So the institutional knowledge base is growing. So the benefit of this kind of real-time insight is really for Alpla is much higher productivity for the factories. Labor costs are better as well. Just because they can deal with turnover, and employees on the factory floor reach full productivity sooner. So it's a great example of how this machine data and predictive analytics and other new techniques are really helping a very traditional manufacturing company modernize. So systems like Alpla's, which include machine-generated data, machine learning, artificial intelligence. These have a huge appetite for data, and what we'll talk about today is really this new data workload. In Alpla's case, really the data variety is pretty intense. So, in each factory, you have about 950 different types of sensors sending data to this system, and the handful of machine data operators in there. You also have natural language, right? So there's some searching of the logs and the notations, the notes that the operators are entering, just documenting, techniques and resolutions and things like that. There's data that they're integrating from different systems like ERPs, like material suppliers. If there was a quality issue, can that be related to the provider of the raw material for that run? Right, as well as HR data, like who was on hand when where certain people tend to be on hand, or supervising the equipment when things go super well or not as well, and kind of address those HR issues. And the volume of data is another big challenge for them. So hundreds of data points per bottle, actually. Weights, a lot of visual measurements to make sure the bottle is the right shape. And again, millions of bottles per day per factory. Okay, so if we sum up the data management use case or the workload for these smart systems, if we state it simply, it's just a fire hose of complex data in real time, right? And optionally at the edge or in the cloud. And this is really the nature of the data that's being generated by smart systems, and really the opportunity for all of us is to take this data and put it to work in new ways, like Aptla has done. Okay, so clearly, if you're going to do what Aptla has done, you need to replace that question mark in the middle of this operational brain cycle with the right data management solution. Okay, so the right choice is going to be easy to scale as the amount of data increases over time. As you increase your rollout from 1 factory to 180 factories in Alpla's case, from 5 production lines to 1,500. You'll be able to handle a diverse set of data, right? 900 different types of sensor readings, ideally without having to create 900 different types of tables. Okay, and handling a variety of analytics, right? Time series, full text search, usual relational stuff, joins, aggregations, and so on. And the better your database fits these requirements, the sooner you're going to be able to start delivering value. Less work you're going to have to do to get it to be successful. Lower the production costs and everything else. So it really comes down to the right tool for the job, and we'll talk about some alternatives in a moment. But as we know, as builders, if you have the wrong technologies, it's just, you can probably get it done, but at the end of the day, it's going to take longer, cost more. Okay. A couple of misconceptions around machine data handling. Okay, we've just seen these in our experiences working with so many customers building these kinds of systems. The first one is that people look at this and think it's a data workload that their traditional database can handle, right? So Alpla actually, before they turned to Crate, tried to get this done with another relational database. Again, created a different table for each of the 900 different sensor readings. Tried to get sort of time series views on that in real time, and every dashboard was taking about an hour to refresh, right? So that's about the same amount of time it takes an operator to just walk around the factory floor. So that's not really an improvement over manual for them. So they needed a database that could process that data and really show real time, sort of, in their case, mostly time series views, and that was clearly something different. It's great. Another myth is that IoT and machine data is a time series data problem. This one's only a partial myth, right? It's time series data analysis where you're really ingesting a great deal of time-stamped records per minute, per second. This is very often a requirement in systems like these, but it's not the only one. So there are specialized time series databases like InfluxDB and some others that are very good at telling you what's happening when, but when it comes down to the, why is that happening? Where is it happening? They tend to be very good at just a kind of a narrow niche, a narrow part of the machine data management area. So when you want to try to add more data to the database to try to understand why things are happening and integrate more information like data from materials, suppliers, ERPs, or HR data and things like that, then the data integration challenges become kind of painful for those specialized databases. Myth number 3, this workload, this fire hose of complex data analyzed in real time is a NoSQL problem. A few years ago, probably true. And today, these can be addressed through the use of NoSQL databases like Cassandra or Elasticsearch. You see those used sometimes, as well as some of the time series databases. But but that's really no longer the case. So there are new databases like CrateDB and others that have implemented SQL engines in such a way that they're able to scale and handle diverse data and wide varieties of data, like the 900 different types of sensor records, in a way that's very NoSQL-like. And so, which is very beneficial to companies like Alpla and others whose IT departments are already full of people who know SQL very well, who have a lot of tooling and other software that's built to work with SQL databases. And the good news is with technologies like CrateDB, you don't have to throw your SQL expertise and technology stack out the window. You can, in order to use something proprietary like Cassandra or MongoDB, you can now just do that with Crate or with SQL. And the last myth is, we can't start anything AI related or machine learning related until our data is cleansed. And the fear here is sometimes a little science fiction-y, as in like our artificial intelligence will do terrible things if it's making decisions based on bad data. The advice here is, if you wait until your data is all cleansed, you just kind of end up with the analysis paralysis, right? So, data cleansing and has been an IT priority for decades, and it's the kind of thing that you want to cleanse and as you go along in these projects. So get started, see what the system is telling you, pay attention to findings and decide whether you're it's kind of QA as you go along. But definitely start building and iterate and kind of increase functionality and analytics and data quality as you go along. Okay, so that's a kind of a high level on some of the data management sort of situation and challenges with these new operational brain type systems. Now let's look at the technology a little bit. As I mentioned before, the requirements, we're really talking about this fire hose of complex data. So we can be talking about millions of sensor readings, right, or logs, or GPS readings per minute, per second. You need to query those in real time. Okay, a lot of that time that data is JSON, right? So objects. You want to do aggregations and time series analysis, maybe predictive analytics, machine learning, anomaly detection, things like that. And again, get answers really as quickly as you can following the ingestion of the data, usually within a few seconds, so that you can prevent anything that's just prevent suboptimal performance or security breaches or safety issues and things like that. Okay, so Crate is in the business of helping companies do that. Sorry for the sales plug here, but just through the use of SQL technologies that we've developed, it just makes the ease with which these systems can be built, with which they can be staffed, these development projects, the ease with which data can be integrated is so much easier with SQL, just because it's most organizations are already geared up to work with it. And then through unique capabilities in CrateDB and the Crate Machine Data Platform, which I'll explain in a second, you'll understand why Crate's able to kind of deal with the complexity and the iterative nature of the development of these systems, and obviously to meet the performance requirements. Okay, so for those of you who aren't as familiar with Crate.io, we have, we're the developers of the CrateDB database. It's really been our only product for the last 4 years, and it's a distributed SQL database that shards data across a bunch of little Lucene engines, right? So kind of have this SQL database with a very NoSQL-ish feel in some ways. Can be downloaded and run on premises, or we also offer this hosted cloud service, but it's really for teams who have the technological expertise to build a scalable machine data platform. For companies who, and I'll explain the difference between a database and a data platform in a moment, but for those of you who built sort of cloud native systems or large scale production database applications in the past, you know that it's more than just installing a database and hooking it up to a data source and a report on one end and a reporting tool on the other, right? There's security, there's the scaling infrastructure, there's the DevOps, there's logging and data loading and all this other stuff that comes into the picture. And for companies that don't have the expertise to build that. The machine data platform is something we built based on CrateDB and based on our experience working with companies like Alpla and so many others over the last 4 years in this space. That really saves them the trouble of building all that database, all the infrastructure around the database to get it to meet their performance requirements and securely and in a highly available way, 24 hours a day. So that's the machine data platform. But looking into CrateDB for a second, just some of the things that make CrateDB unique. Distributed SQL database, so it's able to gain performance advantages over other databases through parallel processing, spreading the workload across a lot of shared nothing nodes in a cluster. And as I mentioned before, we actually shard the data across a bunch of little Lucene based shards that actually do the processing. And because it's based on Lucene, which is probably most famous as a search engine, it gives Crate the ability, it enriches SQL with really powerful text search, geospatial indexing and querying, and dynamic schemas, really this ability to throw a bunch of different data structures into the same table and be able to query them very quickly. So distributed processing, columnar caches, which help speed up query processing. It's cloud native architecture, which allows Crate to be scaled as you would any container application. And this mix of SQL on Lucene really gives it this unique ability to deal with variety and data variety, data changes, and to scale very simply. Okay. Again, we work with tons of customers building systems like this, and one of the things we've seen over and over again was the development of these machine data platforms and really the infrastructure that people build along with their database, build and deploy and operate along with their database to create these kinds of projects. And you see this over and over again. These IoT platforms and the machine data analytic platforms, they all look alike, right? So underneath the business or the project specific analytics, data enrichment, integrations and data visualizations is a pretty common data management layer, right? It's way more than a database. And whether you're building this is operational analytics for cybersecurity, or whether you're building it to improve the efficiency of bottlenecking or railroad transportation, the data management layer underneath those sort of vertical, kind of project-specific bits is really quite common, right? So it includes a database management system, of course. You're usually the container platform to scale that, identity management and security, logging and monitoring, backup and restore, the overhead of operating it 24 hours a day, alerting and data loading and so on. So this is really, we saw this as an opportunity to create new value, and this is what was really inspired the development of the Crate machine data platform, which does all that other stuff so that people can simply build their project-specific analytics, data enrichment, visualizations, and integrations, and Crate machine data platform really handles the hard data management layer for people who either lack the expertise to experience building that stuff, or those who have it but realize it's not very differentiated investment of resources, and just want to get to market faster with all the more valuable stuff on top. Okay, so now I'm going to turn things over to Dominic, who will talk about the machine data platform in more detail, and kind of how we built these and how it all works, and then we'll wrap up with Q&A. Dominic?
Good. Yeah, I'm here. Thanks for handing me the screen. Good. So we will dive a little deeper into what our platform really does, what it is. So if you look at the slide that we have here, you see that the platform, in essence, which is here below, contains a few key components, which I'll dive deeper into within the next few minutes. So we basically have a key component which is caring about the data ingest. So this is basically the beginning of the data pipeline that we have, using as a first available option the MQTT industry protocol for sensor data communication. Then we have below, like Andy told before, we have the CrateDB as a database layer, which we use to store the data. We use it as well in the Ingest component to get raw data in. We use it here to store the final data, all the applications, all the services run on top, and this is also managing data aging in Restore. Then as well as services, before I come to the core services, we have, of course, this is monitored and logged, also visible to any customer via a separate dashboard, and queryable from the database itself. And you have ID management, which is built in all of these services to ensure access management is taken care of. In the core of this is then several services that can be customized or basically provide a framework for doing data enrichment, data analysis, some visualization, and so named alerting microservices, which provide a framework for getting alerts done, which I also will explain in a few minutes. So essentially, this part, that's basic framework, which every customer can build applications and individual apps or services atop, and these are hosted within the platform, and also are able to customize that. What can be put atop then is different applications, which can be either custom built, or you can use some standard tools if they have a standard SQL interface, for example, because CrateDB, as mentioned before by Andy, is SQL compliant, so you can use everything that can access and work with a SQL compliant database. As in essence, as Andy said before, all of this, so the whole platform, will be fully managed by Crate.io, and it is used with Kubernetes as a container orchestration platform, augmented with proper monitoring and operational support, and backed up by a team of system specialists who will run and operate the platform 24/7 for our customers. All at the moment on Microsoft Azure. That's the hosting services of our choice, and AWS will be available within the next year. If I continue, let's move to the ingest of the platform. So basically what we have here, or what we learned, and there's where it comes to lessons learned really. What we learned with Alpla is to use MQTT and basically work really efficiently with that. So the way it works in essence is we have different MQTT devices. For Alpla, it's in fact, as a good example, they have an edge component included in that game on top. So they have an edge component in the plant which collects data and sends that to the central storage into a central MQTT REST endpoint. So you can have multiple of these. For a reason of simplifying that, it's only one here. So you basically send, you configure on the platform, you configure an MQTT endpoint. You get a customized URL for that, you get a username and a password, and it will be secured via HTTPS. What's included here in that Ingest part really is the queuing of all of that stuff. So no matter if components further back in the pipeline are off or down for maintenance or have an issue whatsoever, the Ingest component will ensure the data is not lost, but it is queued and processing will resume once the backend components are back up. We do this via basically via a simple data model. So whatever comes in MQTT will be stored in the Ingest raw database, as we call it, with three simple things. You will have a timestamp, you will have a topic referring to the exact sensor and the version of the sensor reading, or the data type that you sent, and then there's a payload object, which really is JSON based and which can contain any number of nested data that you have. In this example that I have here, we received sensor data from a production line which is filling beverages, for example. So you have like an ID of that, and you have several values for this. And in fact, here you see there's an array where there's a multitude of objects included in that. This data streams, so to speak, or these raw data streams can contain any type of data really. We can consume raw data of sensors. We can also consume, as we do with several projects, for example, SAP iDocs that are used to ingest planning data into the platform to be later combined with the sensor readings and derive information from that. So really what we continue then with the enrichment, which you see below. So basically the raw data, which is here, which is pure sensor data, and which may be in different formats, because there's a multitude of sensors available, and hardly there's only one sensor within a customer's use. What we will do then is we will take up the raw data storage, and the enrichment services will consume that data and will put that data into an enriched or enrichment part of the database, which is a separated instance of CrateDB, where you will move all that sensor readings into a normalized, so to speak, format that all the applications downstream and the other services atop can then consume in a consistent fashion. For example, as I've put here in the bullet points, you might have a similar sensor. You might have some camera system which visually inspects bottles and how pure the bottle is from a quality perspective, and there might be different types of cameras. All of them might deliver the same values. There might be a newer model which delivers more sensor values, so your raw message might look differently. And in the end, you want to have one application or different kind of services downstream that can consume that data in a consistent way. So you have to bring the data into a specific format, which is then universally consumable by all the downstream applications. So that's what you might do here. You also can, for example, combine different raw data events that you receive. For example, you receive an event which will tell your system that production has stopped. So there's a stop and a stop event of production, and sometime later you might receive a start event of the production once something has been fixed and production continues. And for example, at Alpla, this is combined into one event when doing the enrichment. So we get single events from the raw storage, and we combine that into a single event which tells us there has been a downtime, and the downtime then has a start and an end date, for example. A further thing which we can do here is we can create or update configuration items, which is another piece of thing which we store in the platform. Basically, this provides several contextual information. I will get back to that in a minute as well. Basically, all that enriched data is then taken from this raw storage and is enriched and then stored into an enrichment database, which we call a metric table or metric database, or it is stored into the configuration service, depending on what type of data this is and how this best fits the use case. What can be done for you as a user or as a customer in that case is here you can use specific or standardized bits of Python code with standard SQL to define how your enrichment is supposed to happen. So you can specify clearly, based on the type of sensors you have, on the specific sensor data that you push into the pipeline, can define basically the enrichment process and how this is supposed to work. And as well, this is augmented with the user management, so you only get the people or the users have access to this specific piece, or even you can put it down to a table level where, say, specific types of raw data only get accessible by specific users or specific services, for example. Moving on to the metrics and the data store. Once basically we have the enrichment services have run, you want to store that information in the enriched version of the data store. As said, this is a dedicated CrateDB cluster exclusive for by customer, where you store that information, and this is a fully available database, as if you would download CrateDB from our website and install that locally. So it's fully accessible via the standard drivers, either via the JSON or the REST API or via the Postgres protocol that we have. And you can also access its web UI and do queries there in a limited way, as you are used to with CrateDB in a single instance. There's two things stored within that database. For one, it's the metrics. That's the pure sensor data that you have an example listed right here with a black background. That's just a normalized view where you can define a custom schema which fits your application and the purposes that you want to use downstream, or use a standard schema that we have available for normalizing or storing the enriched sensor data here. A second thing which is stored here is the so-called configuration service. You see a screenshot of its UI above here. And the configuration service really provides contextual information on products, product variants, on the configuration of a production line, for example, which could change. There's customers which, like Outlier, which change those depending on what type of product they produce, like sensors may be moved back and forth, might get a different purpose, for example, and to make all the downstream services aware of such changes, or to help to interpret sensor values in a different way, this configuration service really can be used. And you can link different objects together, build a hierarchy, and you can even do more than that. You can build a graph of different configuration items and link them together and have the downstream services honor that information and interpret sensor readings based on the context you've put them in based on the configuration. So now we'll move on one of the first downstream applications that we have. This is the alerting service, where you see a screenshot of several alerts, for example, above. This really is a configurable alerting service we call nodes service, really. And this is, again, the nodes can be customized by you as a customers with a simple click-through interface. You provide standard SQL into that interface, and there's a more complex version available, which you also can do coding via Python and insert that into the platform. But the standard one can be configured. You can put in SQL snippets that you can test up front directly on the enriched database, and have the system alert you and push that alerts to different kinds of people or users. As said before, this is considering the configuration and so to speak, the context, so to speak, and the sensor data. And for example, you can get different nodes if thresholds are reached, or if certain events happened plus something else in the enriched database triggers these events. Finally, the last component that we have, there's within the platform, you see a screenshot here of the actual CrateDB UI for managing the platform, where you see there's integrated logging there. This is a view where you can view individual messages, MQTT messages coming in. So that's basically the log screenshot of the database contents that I showed you 5 slides before. And this is all visible. You can filter on that. You can also filter on events that happened in the platform, so sort of operational logs that happen, and can log in directly to the metrics database from here. This all really is tied into the management and authentication framework. So all of these services get attached to users that you can control and define down which users have access to what services and are able to configure those. Good. I believe, Andy, from my perspective, I'm more or less through. So we can open up for questions, right?
Yes, thanks, Dominic. Yeah, we were actually at the pretty much the end of the time we were scheduled to spend. So I'm not sure we'll be able to get to all of the questions, but there are a few quickies here we can probably get through. And if anybody else who has questions, just type them into the questions panel. If we don't answer them here, we'll get back to you via email with an answer. But the one question was on data loading. Let's see what it say here. How to phrase this. The data loading was just. Are you able to use any ETL or any SQL pipelining tool, any data pipelining tool, or are there specifics that we have to use?
You can really use every tool at the moment which is able to ingest via MQTT protocol. So every tool which is able to produce a payload like I showed you in MQTT can connect to the database. Furthermore, you could ingest into the metric store directly, but this would bypass the whole pipeline essentially. So it's not advised to do that.
Okay, thanks. Another question here. Ask whether it's only available on Microsoft Azure. I think you mentioned, and also if it's available to run on premises.
Mm-hmm.
I think you mentioned already that it's a version that can run on AWS in the future. But what about
we're in talks with Amazon. So we're in fact in talks with Amazon on getting this platform onto the premises. We have some past experience with AWS, and we're looking forward to make this happen within the next months. Although we cannot give a fixed availability date on this one to date, but okay. It's certainly an option to do that. Yeah.
Cool. And I think just last question, since we're at the 45-minute mark, is the use of MQTT a requirement in ingestion, or can you ingest into Crate directly without using MQTT?
Within the platform, you could ingest into a metric database directly. Although what our lessons learned was from such large cases, you would have to build a queuing pipeline at some end, and this is currently managed via the Ingest component that we have. The plan is there to extend that, being able to accept SQL bulk within the next month. So you would have that capability there. But for example, if you forgo the platform as such in this big extent and only say I only want a CrateDB as such, so basically you just focus on the lower part with the database, for example hosted on Azure, you can ingest to the database directly with all the protocols that it has usually available. Besides MQTT, because in the hosted version that we have, the MQTT one is not available outside due to the Kubernetes restrictions that are there. So therefore we suggest there to use the ingest component. But if you host it on your own or host it somewhere else, or use any other protocol than MQTT, that would be perfectly fine.
Cool. Thank you, Dominic, and thank you everybody for attending today. We will follow up with all of you with an email with links to recording of the session today, as well as the slides, and wish you the best in your future or in your data management projects, and feel free to get in touch with us directly or through the crate.io website if we can be of further help. Thanks again.